Let's begin with the first problem about related rates. Take, for example, a boy named Mark observed a pile of sand form into a shape of a cone. Mark assumed that the sand is being poured at 2 cubic meters per second. He also assumed that the height and diameter of the base is equal to 8 meters. Now, he wants to know how fast the height of the pile is increasing with a given measurement of the base. In order to fully understand what the problem is all about, we need to draw a free body diagram. The height of a pile of sand is equal to the diameter of the base, which is 8 meters. The derivative of volume with respect to time is equal to 2 cubic meters per second. Let's begin with using the formula in getting the volume of the cone, which is 1 over 3 pi r squared times height. However, we cannot directly use this formula considering that there are two variables involved. Since variable h is needed to determine how fast the height of the pile is increasing, we should write r in terms of h. But since the base is measured in diameter that is equal to 8 meters, then the radius is 4 meters. R in terms of h is now equal to 4 over 8. We need to cross multiply, making it 8r is equal to 4h. Isolate r by dividing 8 in both sides. We now arrive with r is equal to 4 over 8 times height, making it r is equal to 1 over 2 times height. Let's go back to the formula of getting the volume of the cone. V is equal to 1 over 3 pi r squared times height. Replace r to 1 over 2h. 1 half h raised to 2 is equal to 1 over 4h squared. We can have the formula V is equal to 1 over 3 pi times 1 over 4h squared times height, or equal to V is equal to 1 over 12 pi h cubed. Let us differentiate both sides of the equation with respect to time. The derivative of volume is derivative of volume with respect to time, while the derivative of 1 over 12 pi h cubed by constant multiple rule is 1 over 4 pi h squared times the derivative of height with respect to time. Let us isolate the derivative of height with respect to time by dividing both sides by 1 over 4 pi h squared. Simplifying, we can have an equation of the derivative of height with respect to time is equal to the derivative of volume with respect to time divided by 1 over 4 pi h squared. Plug in the value of the derivative of volume with respect to time, which is equal to 2 cubic meters per second, as well as the height of the sand equal to 8 meters. Simplify the denominator to get 64 over 4 pi. Divide 64 by 4 to get 16 pi. Finally, we can have an answer of 1 over 8 pi meters per second. This is how fast the height of the pile is increasing.